There are moments in concept mobility where the object in front of you feels less like a vehicle and more like a thesis on scale, presence, and engineered authority. What we are examining today is one of those studies. This is not a production motorhome. It is an AI-generated speculative design exploration, a conceptual exercise in luxury overland architecture rendered with extraordinary conviction. It does not exist physically, yet it is structured with enough engineering logic to merit serious analysis. And that is precisely how I will approach it. From the first glance, the proportional mass immediately communicates that this concept redefines the conventional RV typology. Instead of adopting the tall, slab-sided camper silhouette common to the segment, this vehicle leans heavily into armored expedition truck language, blended with executive limousine cues. I estimate the overall length at approximately 7.5 to 8 meters, with a width approaching 2.4 meters and a height likely under 2.8 meters to maintain structural rigidity and aerodynamic manageability. The roofline is surprisingly controlled for a motorhome of this visual mass, suggesting a deliberate attempt to keep the center of gravity lower than traditional Class B or C architectures. The three-axle configuration is central to the design thesis. The extended wheelbase, paired with the tandem rear axle setup, implies a gross vehicle weight rating well beyond standard camper vans. This is a platform designed to carry substantial battery mass, water storage, interior build-out materials, and structural reinforcements without compromising ride stability. From an engineering standpoint, a triple-axle layout dramatically improves longitudinal load distribution. It reduces rear overhang sag under heavy payload conditions and increases braking stability by expanding the contact patch footprint. In real-world heavy mobility platforms, this configuration would also enable air suspension load balancing across each axle. The stance is wide and assertive, yet not flamboyant. The wheel arches are squared and armored, visually reinforcing structural protection while managing debris projection from oversized tires. The front fascia leans into aggressive faceting rather than flowing curvature. That tells me the design language is intentionally architectural rather than organic. However, beneath the visual aggression, there is aerodynamic intention. The hood slopes gradually, integrating multi-channel venting that suggests controlled thermal evacuation for a high-output hybrid system. These vents would, in a real-world execution, reduce front-end lift by extracting high-pressure air from the engine bay or battery cooling modules. The A-pillars are moderately raked, more so than typical expedition vehicles. This reduces frontal drag and wind noise at highway speeds, a critical consideration for long-distance touring platforms. The roofline maintains near horizontal continuity, but its edges are chamfered. That chamfering likely serves as a vortex management strategy, guiding airflow cleanly toward the rear without turbulent separation. The rear profile, though not fully visible, appears squared but not abrupt. I infer a slight tapering in the final section to reduce wake turbulence. In a production-grade wind tunnel, a vehicle of this frontal area would require extensive underbody smoothing and diffuser channeling to maintain efficiency. The glass-to-body ratio is restrained compared to typical RV architecture. That is a significant design decision. Traditional motorhomes prioritize panoramic glazing for lifestyle marketing appeal. This concept prioritizes structural integrity and thermal performance. The side windows are elongated yet narrow in height, which reduces heat gain and improves torsional rigidity along the sidewalls. In a real-world build, these would likely be multi-layer laminated acoustic glass panels with electrochromic tinting capability. Electrochromic glass would allow dynamic opacity control, balancing privacy with panoramic experience. The engineering challenge here would involve maintaining insulation values comparable to composite wall panels while avoiding thermal bridging along the frames. The front windshield appears thick and upright enough to maintain impact durability while still offering commanding visibility. The deep burgundy metallic finish is layered and complex. Under controlled lighting, it exhibits high reflectivity along convex surfaces while absorbing shadow across recesses. This indicates a multi-stage paint application with metallic flake suspended within a high-gloss urethane clear coat. In high-end automotive finishes, such layering enhances depth perception and perceived quality. Lower cladding is finished in matte graphite or satin metallic gray, visually lowering the vehicle's mass while protecting high-impact zones. From a material science perspective, these panels would ideally be reinforced polymer composites capable of absorbing low-speed impacts without cracking. The lighting architecture is distinctly modern and layered. The DRL signature forms a geometric perimeter around the headlamp clusters, emphasizing width. The front light hierarchy suggests a multi-tiered LED matrix system. In a realistic deployment, adaptive beam shaping would be critical for a vehicle of this size to prevent glare and improve nighttime maneuverability. Underbody accent lighting and side illumination strips create a floating effect. While visually dramatic, their functional role could include terrain visibility during low-speed overland travel. At the rear, symmetry appears prioritized. A horizontal light bar would reinforce width and provide clear brand identity at night. The wheels are large, likely 20 to 22 inches in diameter, with low-profile all-terrain tires. This is an interesting duality. The rim design is aerodynamic yet open enough for brake cooling. Given the vehicle's mass, braking hardware would need to be commercial grade, possibly multi-piston calipers with ventilated rotors approaching 400 millimeters in diameter. Suspension would almost certainly require adaptive air systems. This allows ride height modulation for highway efficiency versus off-road clearance. Load compensation algorithms would redistribute pressure between the tandem rear axles depending on payload and terrain. The roof architecture is one of the most intriguing aspects. It integrates what appears to be modular panels, possibly solar arrays embedded flush within a structural rack system. In a realistic engineering scenario, solar integration on a surface area of this size could generate meaningful supplemental energy, perhaps 1.5 to 2 kilowatts under optimal conditions. Satellite domes and sensor pods appear mounted at strategic corners. These would, in future long-range mobility platforms, support Level 2 plus semi-autonomous highway driving and remote terrain mapping. Structurally, roof reinforcement would be essential to maintain torsional stiffness given the cutouts required for skylights or modular panels. This concept does not merely upscale an RV, it reframes the motorhome as a mobile command architecture. It leans heavily into aerospace and armored executive transport influences, rather than traditional recreational vehicles. The intended user archetype is not the casual camper, but the long-distance executive explorer, someone who values autonomy, structural solidity, and controlled luxury. From a maturity standpoint, the design language feels 70% evolutionary and 30% speculative. The proportions are believable, the detailing is ambitious yet grounded. My first professional impression is that this concept demonstrates a coherent design philosophy anchored in structural realism. It avoids fantasy curvature and instead focuses on plausible engineering aggression.
Even though we do not see the interior, the exterior engineering tells us how the cabin must logically be structured. Given the extended wheelbase and triple axle distribution, the interior likely follows a front cabin command module, followed by a mid-lounge and rear private suite configuration. The structural load paths would run longitudinally along reinforced side rails, allowing the floor to support heavy battery modules beneath without compromising headroom. Ceiling height would likely measure approximately 2 meters internally, sufficient for upright comfort without raising the external silhouette excessively. The rearmost section is the most logical placement for sleeping quarters. This benefits from reduced road noise due to distance from the front axle. Thermal insulation would rely on layered composite walls with closed-cell foam cores. Acoustic damping mats would mitigate vibration from the tandem rear axle assembly. Electrochromic glass panels would balance privacy and light exposure. The central section would house a compact galley optimized for weight efficiency. Induction cooking surfaces would reduce open flame risk and integrate with a lithium battery bank. Water storage would likely be distributed longitudinally to maintain balanced weight across axles. Gray water recycling systems could extend off-grid capability by several days. A modular wet bath would conserve space while enabling full functionality. Ventilation would require roof-integrated extraction fans paired with humidity sensors. Water reclamation filtration would significantly enhance autonomy in remote environments. The cockpit likely features a digital instrument cluster with augmented navigation overlays. Given the vehicle's width, blind spot monitoring and 360-degree camera arrays would be essential. Control hierarchy would need to be intuitive, avoiding excessive touch-based dependency given off-road vibration. A hydrogen-electric hybrid architecture would be the most plausible future-forward configuration. Hydrogen fuel cells could provide sustained cruising range, while high-density lithium battery modules deliver peak torque during inclines. Regenerative braking across 3 axles would significantly improve efficiency. With integrated solar contribution, total off-grid autonomy could reach several days under moderate consumption. Climate zoning would allow separate temperature management between cockpit, lounge, and sleeping areas. AI environmental adaptation could adjust lighting, airflow, and tint opacity based on external conditions. Structural health monitoring sensors would track chassis stress over time. Long-distance touring would be highly feasible given the extended wheelbase and likely air suspension smoothing. Seasonal adaptability depends heavily on insulation thickness and battery thermal management. Remote work practicality would be excellent with satellite connectivity and noise isolation. However, terrain limitations would emerge in extremely tight forest trails due to length and turning radius constraints. For this concept to become physically viable, advancements in lightweight composite structures and battery density would be required. Hydrogen infrastructure would also need significant expansion. Is this evolutionary or revolutionary? It is evolutionary in architecture, yet revolutionary in positioning. It suggests that future luxury motorhomes will no longer resemble recreational boxes, but rather autonomous mobility sanctuaries engineered with executive-level structural intent. And that, ultimately, is what makes this concept compelling.